Hey, everybody. Welcome to IAEI News Live. Thomas Dimitrovich here, and waiting in the background, we've got Keith Lofland and Chuck Mello, the authors of the SOARES and Grounding book. Today's discussion is on SOARES, Grounding and Bonding, the reference, and it starts now. All right. Mr. Chuck Mello and Keith Lofland, the Chuck Mello and the Keith Lofland.
Absolutely. Yeah.
And this is awesome. So I really appreciate both of you taking time out of your day to talk about, I think, one of the most easiest topics, most understood, less argued about, grounding and bonding. So
now, what have you been smoking, Tom?
Exactly. So what I first want to do is, I know, Keith, you've been on here before. What I'd love to do, though, is I'm going to give you the floor, let you give your background, let everybody know who you are, and then we're going to move to Chuck Mello. So Keith, why don't you do a little introduction?
Well, a privilege to be here with you guys today. My name is Keith Lofland. I am the Director of Technical Services with IAEI. I have been with IAEI for over 21 years now, and I also serve as chairman of Code Making Panel 7 for the National Electrical Code. I believe this is my 5th code cycle on the code making process. When it comes to the SOARES Grounding and Bonding, Chuck is the one that actually updates the text, and then I come back behind him and I update the illustrations and photos and things like that. And so it's a cooperative effort there and labor of love there. And so, Chuck, we're awful glad to have you with us today as well.
Yes, Mr. Chuck, the Chuck Mello. Why don't you give us, I don't believe anybody, at least on this channel, I'm sure there are a lot of people out there who know you because you do get around to a lot of section meetings and whatnot. So why don't you just introduce who you are, give us a little bit of your background.
Sure. Thank you, Tom. And again, it's great to be here with you and just sitting in this forum with Keith and yourself, two icons in the industry also. So I am Chuck Mello. My background is an electrical engineer. From training-wise, I spent most of my life in field engineering, field type work. Spent 13 years with UL as a field evaluation program manager. But actually, even from my college days, grounding and bonding has been a passion or a topic that's had interest to me. I started contributing to the SOARES book in the early stages with Phil Simmons' time in the 90s. And then later on with Mike Johnston, and now with working with Keith, doing the main updates for the text and some of the graphics input to him. I am set on Code Panel 5 for 7 cycles from 1996 through the 2017 cycle as a principal member representing NETA to start with, and then UL with that. And in addition to being the training for electrical engineer, I still hold an active master's license in the state of Colorado. So I've been on that side of the house. But most of my time has been field work, but definitely a passion for grounding and bonding.
Awesome. So you're well grounded.
I'm well grounded. Ready for the lightning strike.
Now, wait, so you were on panel 5 for grounding and bonding. Yes. When, as far back as when?
I came on in the 96 cycle. 96. The end of the 96 cycle, I went all the way through the 2017 cycle. So 7 full cycles.
Wow. Okay, that's pretty cool.
So when we had the grounding and bonding reorganization of Article 250 in 99, and Phil Simmons was the temporary chair of that, I was part of that committee that did the parallel writing of Article 250, because if the organization didn't go through at the thing, we had to revert back, and we didn't want to lose the technical changes. So the panel actually wrote 2 complete Article 250s in parallel, which was a challenge.
Wow, that's a lot. I mean, and I know just doing small rewrites, like on panel 2, we looked at Article 220. I know that was a lot of work. I can't imagine 250. Article 250 is huge. I mean, that's huge.
Yes.
But again,
I remember that 99 rewrite, and Mike Johnston was working at IAEI at the time, and he called it a significant emotional event.
Oh, yes.
Yes.
Oh,
And
yes.
the whole topic of grounding and bonding has received a lot of attention. And I just go back to my copy of SOARES Grounding and Bonding book. Okay. This is the one I have, my oldest one that I have, and it goes to it's the third edition,
Right.
1987.
So if you want, here's the first edition.
Wow.
SOARES Grounding and Bonding. That's the blue book, which is 1966. This is the actual one written by SOARES. And then the copyright was transferred to IAEI to Bill Summers in 1981. And so Bill Summers did the 1981 second edition, which is really just an update to the SOARES, original SOARES work. And then the 87 edition, your third edition, was the third. And then starting with 1990, Phil Simmons picked up the lead on it, and we have had updates every code cycle since.
Okay. So, I mean,
I get asked from time to time, where did IAEI come up with that name SOARES? And
yeah.
Chuck just briefly touched on it there. It was originally written by a gentleman named Mr. Eustace SOARES. Chuck's probably old enough that he knew Mr. SOARES. No, I'm kidding. But Chuck, talk about Mr. SOARES just a little bit.
Oh, yeah. Eustace SOARES was a professional electrical engineer and actually, honestly, was well ahead of his time. And with the 1965 code, and there's the acknowledgement in the SOARES book today, and a whole appendix on the write-up there for his background. But he was an electrical engineer that saw a lot of problems in the grounding and bonding and the understanding of it in the language, and really kind of took on that there was a lot of traditional hand-me-down stuff coming from there. And I think we see this a lot in the industry. We have the journeyman teaching the apprentice, or the master teaches the journeyman teaches the apprentice, and you have, like the old telephone, you have that hand-me-down training, and it isn't always quite exactly handed down the same way to the same people. So we have these wide variances that happen, and a lot of people got hung up in tradition. So one of the things SOARES did was identify in his book in the first edition, here's a number of things he saw as problems. One was tradition, where people need to really understand what they're trying to do with grounding and bonding. And the second was using clear language. We have this thing, go connect to the ground terminal. Okay, what's the ground terminal? Is that the terminal for the white wire that's colored silver, or is that the green colored terminal that has the equipment ground conductor? Could mean, depends on your point of view. So again, proper language is very critical, and we have that. The main thing SOARES pointed out in the his book with the 65 code, we had one term. We had grounding conductor. That was the term. And the grounding conductor represented the grounding electroconductor, what we now call the main bonding jumper, system bonding jumper, supply side bonding jumper, equipment grounding conductor. Those were all just grounding conductor. And it becomes, if you think about it, it becomes extremely confusing when you have one term meaning all those different things, which have different purposes, connecting the earth or connecting things together that carry fault current. And how do you size those and all those kinds of things. So SOARES actually identified about 11 different things that needed to be fixed. And in the present book, as it was revised in chapter 1, a lot of those are discussed. So
yeah, I started to say you tackled that in this latest edition, and we kind of expanded on those a little bit there in chapter 1.
Yeah, and I'm going to have there's a link down below, up above, left or right, whichever platform that you're on watching this, so you can purchase your copy. And I think these are only like $75 or $78 or something like that. So it's not a very expensive reference, but a lot of really good information that, and how often do you update it?
Every 3 years with the code cycle.
With the code
cycle, yeah.
Now that has been what has been going on. So that kind of leads a little bit to this book. What's the big deal with this book? Because honestly, in the 2017 to 2020 code, there were a few grounding and bonding updates in 250, not a huge number. But what was the real change in this book? And that was the thing. It was really had evolved over time into what I felt was a mishmash of topics. The flow wasn't really very well there. And it was also a very extensive book. If you try and consider teaching kind of thing, to try and teach a whole source book as it was written would be really, really difficult. So what we did in this 14th edition, which is a really radical thing, was we actually made it into three parts. So we reorganized the book into three parts. Part one is the history and the fundamentals of grounding and bonding. Part two is your motherhood and apple pie, day-to-day services, separately derived systems, buildings with feeders and branch circuits, grounding electro conductor, equipment grounding kinds of things. And then part three is all the special applications you get in with hazardous locations, healthcare, facilities, alternate energy, which is growing very fast. The alternate energy chapter actually didn't happen until 2 editions ago. It just got started. So that's new in the book there, and it's greatly expanded, doubled in size for this edition. High voltage, lightning protections touched on a little bit in there. So all the part three is the specialty stuff. And by having this organization like this, excuse me, you can now teach it in pieces and it kind of has a flow. Because as an example, one of the things that bothered me was we went through and we did services and bonding and some equipment grounding. Then we jumped and did short circuit protection. And then we did separately derived systems, second buildings. Then we did ground fault protection.
Yeah.
Well, short circuit protection, overcurrent protection, short circuit overload, and ground fault kind of should go together. And those are really fundamentals because they're really talked about in chapters 1 and 2. That's why you're doing grounding and bonding and making sure the overcurrent device works. Well, you need to understand how the overcurrent device works. So just those things in the book didn't seem to flow right. So that's why we did the reorganization.
That's pretty cool.
Yeah. Yeah, chapter, as Chuck said, part one, Chuck did a great job this code cycle. The first chapter is the language of grounding and bonding. And as Chuck talked about, and even, gosh, to this last code cycle, we were still trying to get away from even the code panels using that grounding conductor as kind of a catch-all phrase. And well, what grounding conductor? Tell us what you're talking about. Tell us, are we talking about the equipment grounding conductor, grounding electrode conductor? What are we talking about? So, and in that first chapter, talking about how critical it is to use proper terminology is discussed and goes into a lot of the definitions associated with grounding and bonding. And then chapter 2 is grounding fundamentals. And then chapter 3, we talk about grounded systems versus ungrounded systems. And then we talk about grounding of electrical systems. And then, as Chuck alluded to, chapter 5 is clearing ground faults and short circuits. And then chapter 6, we end part 1 with chapter 6 talking about ground fault protection. So, as Chuck said, you know, those were kind of scattered throughout the book. And you're going to get that. I mean, every now and then, all three of us on this call here have been involved from time to time whenever we have to reorganize a chapter in the NEC. This last code cycle, Article 220, kind of went through that.
Yeah.
And the same thing happens, you know, with a document like the SOARES Grounding and Bonding. You know, over time, you know, you add stuff here and you add something over here, and before you know it, you know, you have to go to a couple of places to find all the requirements for, you know, clearing ground faults and things like that. So Chuck did a great job this last code cycle, the 2020 code cycle, and bringing all those items together, and even the parts, the 3 parts that Chuck talked about. They do have a better flow to it, I guess, especially from a teaching standpoint.
I think that's that makes a big difference, because when it's not until you try to convey a message right? And I think that's what institutes and drives some code changes as well. You get individuals when you're trying to explain something and you start using the resource, that you start to realize, wait a second, we can reorganize this a little bit. It's not that you're changing the technical content, but usability and being able to access information correctly and make sure it's logical. That helps from a safety perspective because now you understand it. And that's an important aspect.
From a instruction standpoint, teaching standpoint, and we talked about chapter 1 and the proper language of grounding and bonding. And I mean, I bet there's been a dozen times over the years where somebody in a class of mine would say, hey, let's talk about a U for ground here. And as the instructor up there, I just simply say, I don't know what you're talking about. What are you talking about? What's a U for ground? Well, of course, I know what a U for ground is, a concrete encased electrode, but there may be people in the audience that don't know what a U for ground is. And so it's paramount that you get everybody on the same page and make that guy say concrete encased electrode, not U for ground. And speaking of that, we even have an annex on that, don't we, Chuck?
Yes, we do.
Where's the let me ask you, where's the annex material at? So
in the very back of the book.
In the very back.
Well, when
Annex A, Annex B.
Is it before or after the? I love the part that says answers. I gravitated right to that. Is it before the tables?
It's right after the tables.
Okay, after there it
Annex
is.
A talks about the origin of a concrete encased electrode, and that's where you're going to hear that name, Herbert Ufer, and
there it is.
Being kind of the godfather of concrete encased electrodes. And then part B gets into the National Electrical Grounding Research Project. That's a very interesting project. And Annex C just talks about the metric system versus the foot-pound.
Oh my goodness. Look at this. On page 412, there's a picture of H.G. Ufer.
Yes.
There you go.
That's pretty cool. Looks just like you, Keith. Okay.
One of the things Keith brought up that's interesting.
That's actually a compliment, Tom. My granddaughter this morning told me I look like Olaf from Frozen. So go ahead, Chuck. I'm sorry.
No problem. Back in the chapter 1 thing, the other thing that's different in the book is, and I think Keith alluded to it a little bit, is we have taken all of the definitions related to grounding and bonding, any of those terms used anywhere in the book, and we've put them into chapter 1. And we have some general terms ahead of time that are not necessarily Article 100, things like electromotive force and what is capacitance and inductance, general terms. Then we get through the Article 100 terms in alphabetical order. So all of that terminology is there. So anywhere in the book, in the very beginning of the chapter, there's a little header that says definitions, and it says, here's the terms that we're using in this chapter. And if you want to refresh your memory in the definitions, go back to chapter 1. That's where they are. So we identify the words used in that chapter and send you back. Now, when the PowerPoint presentation, Keith did a phenomenal job here, is that because sometimes you take the PowerPoint presentations and it's kind of self-contained, you may do a PowerPoint just on separately derived systems. Those definitions are then embedded in the PowerPoint in the chapter for the PowerPoint. So it's readily available. You don't have to go back to chapter 1 in the PowerPoint to do that necessarily. So it's a good combination of the book references, because the book's all there, and then the PowerPoint integrated and not necessarily make it absolutely lockstep. So again, as a teaching aid.
The SOARES book, the layout for the 2020 SOARES actually kind of reminded me of where we're going for the 2023 NEC.
Yeah.
With all the definitions in the 2023 NEC being put up in Article 100, and Chuck kind of was ahead of folks and actually did that with the SOARES in the 20 code cycle, like you say, because I mean, we had the definition of a grounding electrode 4 times. in the
At least. Yeah.
scattered throughout the book. And like Chuck said, they're still repeated in the PowerPoint, but that's because the PowerPoint, a lot of times people will break up the PowerPoint and rather than having to go grab a slide out of part 1 and dump it into part 3 and all, they're already there for you in the PowerPoint. But in the book, all your definitions are in that chapter 1, similar to, again, where we're going for the 2023.
There's something to be said about being able to go to one location to find information. So I sort of like the concept. I mean, we all, everybody learns differently and everybody will use resources differently. But I like to be able to go back to one location for definitions, but it's just me.
Yeah.
Again, and my background is an engineer, and UL world definitions are in most every other standard, mechanical standards, other electrical standards, IEEE. Those definitions are always in the front. They're in a specific section, and they're in a P document. So the NEC is a little different when they were scattered in. And there was always that confusion. Does that definition apply just here, or does it apply elsewhere? Because a perfectly good example is the word tap. Because in grounding and bonding, we talk about taps. We tap the grounding electroconductor. But does that tap have to comply with 240.21 for taps? Well, no, that doesn't make sense. But that's where the definition of tap is. And so this is where definitions in the front there, I do think with the change in 2023, there's probably going to have to be another cycle to kind of smooth some things out to make sure that that flow is correct, so it doesn't get inadvertently a definition messing something else up.
Yeah, they've already identified examples of where there's one term defined 3 or 4 different ways, and they're very similar to each other. But if you're using the same term differently, depending upon the chapter or the article that you're in, that can cause confusion. It really can. So,
well, Tom, what about the term equal potential plane? If I have equal potential plane to protect people in Article 680, 682,
yeah,
that's very different than an equal potential plane to protect livestock in 547.
yeah.
I will tell you, a dairy cow is much more sensitive to very low voltages than a human is.
Well, and is it? No, wait a second though. When you say sensitive, you don't mean necessarily that it's going to kill them. You're talking like milk production and things of that nature, right?
There is milk production and all that, but unfortunately with dairy cows is that if you start not dropping the milk and reducing it, you increase bacteria.
Yeah.
And the cow will stop eating, stop drinking, and eventually, and there have been definite documented deaths from cows because of trickle voltage or trickle shock hazards that has been in the dairy herd.
Yeah,
and I've experienced that myself. So.
Yeah, and they don't drink, because I know that there were cases. There was a gentleman with the IEEE that did a lot of IEEE papers on this topic, where they noted that if there's that voltage potential, the animal, whether it be a cow or whatever it would be, when they touch the water, they feel that tingle, so they're not drinking. That hurts the milk production. And to your point, I never thought about the bacteria. So there's different reasons that we ground and bond and create those equipotential planes, which is a good point. Very good point.
Article 547, of course, is under the purview of Code Making Panel 7, which I happen to chair, and with the definitions all going to Article 100, we had to work very hard with Panel 17 to come up with a definition that would work for both. And I think we have, but we'll see when we get to the 2023 code. But from our standpoint, like Chuck said, I mean, we had to, whatever definition we came up with, it had to work with that livestock in mind and their production and so on.
So I think this brings up a really interesting point, that Article 250, which is your grounding and bonding requirements, Chuck, that's your playground, and Keith, your playground is the marinas and 250. The principles of Article 250 apply throughout the National Electrical Code. Yeah. So the fundamentals of the bonding and how you bond and what the grounded conductor is versus what the grounding conductor is all of those basic fundamentals are still used and referenced in other codes. But
Yep.
you have to understand, which is probably why when I look at part one of this book, it starts on page 4 and it doesn't stop until it gets to page 109. Okay. So if you think about the fundamentals, with those fundamentals, you can start to understand why Panel 7 does what they do with regard to marinas and RV parks and things of that nature, and what the cattle industry or the farm agricultural industry does with regard to this. So the 250 sets the ball up, but then the other parts of the code actually implement what's in 250. Is that?
Yeah, and if we get a public input on Panel 7 for Article 547 for agricultural buildings or 555 for marinas and so on, and it has something to do with grounding and bonding, we're going to put in a rule to talk about bonding of all non-current carrying metal parts around a marina or something. Well, I mean, it's just second nature.
Yeah.
We're going to have to, before we put that in the code, we're going to have to pass that under Panel 5's nose and get their blessings, and make sure it lines up with, the general principles of grounding and bonding in Article 250 before we put something in 555 on grounding and bonding.
Yeah. What do you think, Chuck?
And actually, I was going to say is that then, back to the definition of the equal potential grounding is, it's interesting that a lot of the proposals to establish a common definition came to Panel 5, but Panel 5 never had purview of that definition. It was always Panel 7 and Panel 17 had the purview. So we kept getting these proposals and comments, and we kept saying, not our world. We'd love to help you, but it's not our world. But yeah, definitely those fundamentals are in Article 250, Tom, and 90.3. You're exactly right. It applies even in the chapters 4 or 3 or whatever that gets into some of the grounding. There's interrelationships there, as well as the chapters 5, 6, 7, and even a little bit of 8 comes in there, going back to those basic principles. And one of the key elements, part of this too, is understanding the difference between system grounding and equipment grounding and bonding. Systems are about the power system, and equipment is about the non-current carrying parts. And too many people just lump those together, and they don't separate or understand talking about system versus together. And an example is in the 2020 code, there was an informational note added to the grounded conductor to say that the equipment grounded conductor, the green wire, is not a grounded conductor. Well, yes, we understand that. But if you carefully read the definition of the grounded conductor, it is a system or circuit conductor. That's in the definition, a system or circuit conductor. Those are normal current carrying conductors.
Yeah.
That's what they are. And that would be not an equipment grounded conductor. That by definition is not a normally current carrying conductor, if you understand those fundamentals. But we have to kind of put some band-aids in the code every once in a while to help people understand that. But yeah, there's some really deep nuances there. If you get down to, 250.4 has got a ton of information that's brought out in there. If you really understand those performance requirements, what they are there. And the Keith's point on the equal potential bonding kind of thing is the definition maybe could be the same. Now the performance of that, how that's accomplishing performance, then the two panels can deal with the implementation of that. That's really where it is, which goes back to style manual requirements, and all that should not exist in definitions. It's just define the term.
Yeah, and if I look at your part 1 in the SOARES Grounding and Bonding book, you've got the language which you talked about, which is the definition. You got the general fundamentals, which I think establishes that foundation for you. But then you have the concept that you just talked about, whether the system is grounded or not grounded, which is separate from how we bond everything. And I know that's a point of contention on what do we call it? Bonding? Do we call it grounding? And that whole debate and discussion, because I know there are people on both sides of the fence on some of the terms that we use. But I think that's, to your point earlier, if you go back in time with Eustace SOARES and you think about all the different conductors that were identified in this system, it's not until today that we, and through the years of refinement, that we've taken the time to define the main bonding jumper, system bonding jumper, all these different parts of the grounding and bonding system. Because what do we have to do? We have to understand how to size them, how to protect them. Okay, and if you understand
what
that
rules apply to it, yeah,
right. I mean, and that's why you've got definitions. If you think about it, Keith, I mean, panel 2, you know, we do a requirement for ground fault circuit interrupter protection in a crawl space. All of a sudden, nobody knows what a crawl space is because now you have the requirements around it. And the same thing with grounding and bonding. When you have requirements on, I need to size this one conductor, you've got to go, well, what is that conductor? What do you call it? And then you got to define it. And it's got to be clear so you know exactly what portion of the circuit you're talking about.
Yeah.
Tom, you brought up the ground fault circuit interrupter and just reminded me of one of my favorite slang things I do with the apprentice classes and talking journeyman and all that is, what is a GFI?
Oh, yeah.
Everybody says GFI.
Yes.
And okay, do you mean ground fault circuit interrupter that protects people, or do you mean ground fault protection that protects equipment?
Yeah. And
guys, those are really different animals. One's in milliamps and one's in big amps.
That's right. And you know what? The other thing is, Chuck, the 2023 cycle is introducing again the special purpose GFCI.
Yes.
And there are requirements. Yeah, so that's we're calling it the SP GFCI, and we just had a task group associated with it. But you know what the important part of that is, pertaining to this discussion, in my opinion, is when you install those products, there's a requirement in the installation instructions and in the listing requirements that the equipment grounding conductor has to be of a certain size. Mm-hmm. And the reason is because of the voltage drop. They want to limit the voltage across the body. So here we have a true overlap of grounding and bonding, equipment grounding conductors, and the sizing of that in regard to the performance of the overcurrent device, which is a part of the discussion in part 1 in chapter, where do we talk about it in? I just lost my...
Look at chapter 6. If you go to chapter 6 on page 92, there's a table there, and this is a table, Keith, we put in 3 editions ago, something like this, fairly recent and all that. But basically, ground fault protection devices, and it talks about the GFCI, the equipment ground fault protection device, which is a snow melting de-icing equipment, your AFCI, which has a ground fault circuit interrupter component to it, and GFPE, protection of equipment. And so it differentiates those. Is it people protection? Is it equipment protection? And there was a note added this cycle in the 14th edition about the special purpose GFCI. That note 3 was added this cycle to address that special purpose. And the key is that when you get into special purpose conditions, and why you have that robust equipment grounding conductor, is what you're trying to do is keep the potential that the person is subjected to under the 150 volts to minimize that shock hazard, that shock injury level they're going to have until the device can work. If you try and do applications of 480 volts or whatever with typical Class A GFCI, you're going to have so much leakage just through the normal insulation of no problem, but that leakage is going to constantly be tripping that at the 4 and 5 milliamp trip levels. So that's why the special purpose is higher trip levels, but now you're mitigating that hazard more by having a more robust equipment ground conductor. Oh, and by the way, that's because you're grounding the person and mitigating potential differences.
Exactly.
So you achieve that, by the way, with the equipment grounding conductor that bonds everything together until you get to the service or cyclic drive system, which then grounds everything down. So that green wire does both grounding and bonding.
Exactly. And people ask me, what's the value of a SOARES grounding book? right? Grounding and bonding. And this is the heart of why I've spent so much time in that chapter reading it and rereading it. And I've gone back. Somebody asked me, I pulled strings to find a copy of an older version because there's differences of materials, right? There's like paragraphs that they'll say, oh, there was a paragraph in an older book. So there's so much information in this book that you could read it and reread it and reread it to really understand what you just went through, Chuck, is probably, as I listened to you, it was going, and I'm sitting there like, wow, there's so much information, but everything you just said is right there in that chapter in words, and you just got to read through it a few times to completely understand. In fact, if you go a little further and a couple more, I think it's the next page. If you just look at like the next page, you've got the tripping limits and whatnot. And what we use we use this information in a 70E discussion.
Right.
When we talk about shock and the recognition of the hazards, right? And then there's another table here that talks about the thresholds and also the impedance, the body resistance, the resistance of the body that makes up all of the fundamentals that you just went through to help people understand what is the intent. Why do we ground and bond? And what are the reasons we do that? How does it relate to the overcurrent protection? That, to me, is just something that you not only use in the application of the National Electrical Code, but you use in 70E, safe work practices, and in general engineering, whether you're an engineer, electrician, electrical contractor. There's information in here that would be intriguing to homeowners who want to understand more. Just a layman person who's not an engineer, who's not necessarily in the electrical industry, because the content is really written. It's written very well. It's readable, is my point.
Yeah. And sometimes we get asked, Chuck, sorry, I didn't mean to interrupt you, but why do you have to update it every 3 years, or is it necessary to update it every 3 years? And I did a class the other day, and I started the class off by showing the actual code language of the 1932 edition of the NEC, where it required, I'm not saying suggested, it required you to use the gas pipe as a grounding electrode. And, half a page on how to actually, get that done. Well, of course, today we would be prohibited from using that as a grounding electrode. So, things just evolve and change constantly.
Yes.
But now some things stay the same. In that same 1932 code book, I showed them where the 25 ohms rule was right there.
Mm-hmm.
Pretty much the same thing as it is today, for a ground rod or a ground plate or something that having to achieve that 25 ohms or less if you don't supplement it under today's code. So, the grounding and bonding world is no different than anything else. It just evolves almost faster than we can get it written in the code books.
Absolutely right.
Yeah, and again, I want to add to what Tom was discussing a little bit. The tables you showed there and the hazards, the percentage of population that would be shocked and all that. And one caution that those are for healthy human, male and female adults or children that are healthy, have no cuts in the skin, no losses there. Then we jump into the chapter in healthcare facilities, and the grounding and bonding has to shift quite a bit, because now you have somebody in a patient care vicinity, in a patient care bed, that isn't healthy, may have a catheter in, may have IV in. You've now penetrated the main resistive element for the skin, and you're direct into their bloodstream or into the fatty tissue of the skin. That's why grounding and bonding in healthcare facilities is so much more critical, because where it may take 30 volts, the UL fancy numbers for a non-wet, non-immersed person is for a shock hazard, 30 volts RMS, 42.4 volts peak, 60 volts EC. Those are the magic numbers. And if you're below that, it's generally not considered a shock hazard. Think what class 2 is all about. But you go into a immersed person in a swimming pool in Article 680, there for panel 17, now you're down to like 15 volts, not 30 volts RMS, and so on. Those are your low voltage shock limits there in 680.2 limits type of thing. But then again, healthcare facilities, it can get down to even millivolts, can be enough to drive a fatal current through the heart.
Okay, so where do you talk about that in the SOARES Grounding and Bonding book?
Yes.
Where at?
In chapter 15, not 15, what is it on healthcare facilities? There's a whole thing.
Chapter
Special
16, Grounding and Bonding for special locations?
16.
Tom, do you have the PowerPoint?
Yeah,
that you can pull
which
up,
one do you
or-
want me to put? Which one?
Pull up part 3,
Part 3. Yep.
and just at the very, it starts in chapter 16.
Part 3, so I'm going to grab it real quick. Okay, so here's part 3. Hold on.
And part 3 in the organization did kind of separate some of the pieces that were before, is that we are looking at special locations. It's really the chapter 5 stuff. So healthcare facilities, hazard locations, that kind of thing. Then we have special conditions, and then we have this alternate energy system. So we really kind of separated some of the chapter 5 and chapter 6 things into 2 chapters.
Okay.
Make it look
Tom,
more.
go a couple of slides forward or back. I'm sorry. Go back. We had that list of chapters.
Yep, right there. Chapter
That
16.
right there is actually in the PowerPoint. That's actually a link to all of those chapters. So in other words, if you clicked on chapter 19 there, it would take you directly to chapter 19 in the PowerPoint there.
I
In
like it.
presentation mode, but yeah.
Yeah.
There you go.
But yeah, right there in chapter 16, we get into again the special locations, like Chuck was referring to, like a healthcare facility. And hey, are you having any problems? I bet I get more questions, or I get a lot of questions over bonding requirements for a swimming pool, the equal potential bonding grid around the pool. Guess what? We cover that right here with us in special locations.
Yeah, that's actually in chapter 17, because that'd be Article 680 when in the 17. But yeah.
Well, here's 517.13B1, exception number 2, grounding of switch and luminaires. So this is similar to what you were talking about in the special applications in those different areas. And then what I love now, so the PowerPoint is separate from the book, obviously, but there are a lot of the same images are in the book. But what's nice,
absolutely, so
yeah, and I love the fact that that you guys worked in actual pictures of the installations, and you relate those to the requirements from a graphical perspective. So I can really appreciate, because I'm a visual learner myself, and I like to get my hands on things. So the way the PowerPoint melds in with the book itself, I think is a very important aspect. So if an organization who wants to teach grounding and bonding, you would want to see them buy the book and the presentation, and everybody have a copy of the book, because the materials and the presentation materials are all in concert with the reference materials. So it's important to have them both, is what I'm trying to say in that regard. So and they can purchase both of those, right?
Oh yeah.
And I would So another thing for those of you watching this, please use the chat, because we will be monitoring the chat, and we'll be answering questions and whatnot when this airs. So please use the chat, put your questions in, any notes, any information that we share, because the value of these forums is that we share information, not just coming from us to you, but each other, communicating with each other. So please chat it up.
Tom, if you
Tom,
would go to slide 174 in that part 3, and that's where chapter 18 starts,
Oh yeah.
and that's grounding and bonding of alternative energies.
Oh,
Which,
yeah.
I mean, my gosh, I mean that's exploded over the last decade or so.
Absolutely has. There's a ton of new requirements, and it's going to continue to grow. I know California has requirements where you have to have photovoltaic on structures. There's electric vehicle requirements, electric vehicle charging requirements, and then how are we going to meet the demand of so alternative energy systems, whether it be wind, solar. I guess are you doing battery and whatnot too? I don't know.
Yeah, we do. Yeah, we have that in there. So energy storage systems is addressed a little bit. So we'll go to slide 203 if you would, Tom.
Sure.
Yeah.
So this is a great graphic that really explains 25025, a line side connection for an altered energy system, be it wind, solar, energy storage, whatever you might have as an alternate energy system. So the grounding and bonding of the AC disconnect, that's for a line side connection. This is really a good graphic. And then there's several slides ahead of it that go through a lot of words to explain that. And the book goes into depth of why 25025 is written the way it is and sends you back to 25024 for that grounding and bonding.
Okay. To just I want to know what we're looking at here. So this here is your disconnect that's going to your alternative energy source, right? So
yeah, that is my AC disconnect. That's next to the service, by the service. So I got to be, under the 2017 code, I'd be within 10 feet. 2020 code gave me some of their variances there, depends on wiring and all that. But that's the AC disconnect of the alternate energy service that's near the service. I'm using near generically there.
Right. And
then that is treated just like a service disconnect. It isn't the service disconnect. That's clear. It's not one of the 6 you are allowed to have, but that disconnect is the alternate energy disconnect, but you treat it grounding and bonding wise just like a service, because in a ground fault situation at the inverter, it's going to act just like a load.
right.
The utility is going to still apply ground fault current just as if it was a spa or a load or another building or whatever, because the utility doesn't know that's an alternate energy system. It's just another place to dump power to.
Yeah.
And so if you go a few more slides, Tom, then we can look at it. And this is really where it gets into questions I have. The next graphic pops up there.
Yeah.
Now what happens when we put a transformer in there? And this is where I've gotten a lot of questions recently. Okay, I have a alternate energy system that's generating 3-phase of 480 because I get efficiencies out of that. But my service is 208/120. How do I do that transition? So here's one example of a delta Y transformer that's allowed to step down. And now we're there. And now we get into the thing of alternate energy, grounding, bonding, and separately derived system.
Right.
That gets thrown in the mix. And if you go 2 more slides, I think it is.
Before you do that, though, that transformer, is that transformer low voltage on the right to the high voltage, low voltage on the AC inverter side to a higher voltage, or is it vice versa?
This is going the other way. This is 480 volt delta to 208/120Y.
Okay.
So I'm actually taking voltage down to get into the service because the service is 208.
Gotcha.
If the service is 480, I could do a direct connection. But this is where if you go 2 more slides, this is where the real headache comes. Wow, why transformer?
Why? Because.
Why? Because, yes. And this is
because I said so.
This came out of several inspectors in the East Coast, and then it hit California down in the thing in Pete Jackson's area. And all that is a lot of solar systems are now going, our alternate energy systems, where they have a Y at 480 volts, then they're going to a Y at 208/120. And when you look at the grounding and bonding here, what can be done or how it has to be done, you have to be extremely careful that you don't reground the neutral downstream of the service. That's a boo-boo, particularly if you have ground fault protection. And secondly, is that you want to be careful that, hey, I have ground fault. They're fed through the transformer, again, for that ground fault at the AC inverter.
Yeah.
So, and the utility will feed that through the transformer. So I have to have my grounding and bonding done. So I provide that ground fault circuit path for overcurrent devices to operate on both sides of the system. And generally, we're recommending from SOARES, do not install a neutral to EXO on the 208 120 volt side. You don't need a neutral generally. It's a balanced load by kind of definition. Generally, you don't need a neutral there. And you definitely don't want to bond EXO and HO, because
Right.
then you create an auto transformer.
You know, Tom, from a construction standpoint, you know, building these PowerPoint slides, when you step back and look at that slide right there, boy, you know, that's kind of a busy slide. And that's the last thing you want is, you know, a slide that's just kind of takes your eyes everywhere. But this is a complicated topic right here.
Right.
And that's about the minimum amount of information that you can get away with um, conveying right here
Yeah.
on a slide like that. I mean,
You know what? You know what, Keith? It's like you've got to look at the graphic, almost like words on a page or a few pages of a description, because you could. There's a lot here to take in. Every
Yes.
little wire. You know, when we look, you could try to isolate every layer in here visually and try to find what are my requirements and why is that there? Like, you know, like for example, I'll just use my laser pointer here, but like this orange conductor, and you have your grounding electrode and your grounding electrode conductors, and what is this conductor? Right? Is that a grounding electrode conductor? And I noticed on the previous slide, which I know is a topic of debate, not this one. I think it was this one. You know, we call these power source output conductors. Are these power source output conductors? Are they service conductors? And that gets everybody. I mean, we talk about it. There are a lot of people who probably look at this and go, "Who cares?" Right? But
well,
it matters.
The answer to that depends on if you're asking panel 5 or panel 4
right.
or panel 10.
Or 10,
you know?
yeah.
Or panel 10. And panel 10, those are service entrance conductors. But yeah.
Yeah. And
again, we talk about definitions. This definition of service changed in 2020 code.
Yeah.
Now, it was a significant change, but I don't think a lot of people realize how significant that is there with that change. But yeah, it's, and when you look at it electrically, you can call those wires anything you want to call them. They're going to operate the same way. I call it a service entrance conductor, a power source output conductor. It's going to operate the same way in a current flow, fault current situation. And that's the big deal with grounding and bonding. You have to look normal operation, and you have to think about the abnormal operation.
Right.
The short circuit, the overload, the ground fault. What's going to happen? What wire is going to be affected? How's it going to be affected? And is it going to survive until the protected device operates?
Yeah. And I just had this discussion. We were talking series ratings with an engineer, and trying to help them understand, like, you understand in when you're dealing with series ratings, you're dealing with the motor contribution, and trying to comprehend during a fault condition the flow of current within a power system and how it impacts the performance of the overcurrent devices comes into play, not just in this, but in many other applications in the NEC. So, you know, the one line diagram and all of these diagrams are really critically important to help convey and help people understand the flow of currents in normal and abnormal situations in the system.
In the SOARES book, starting on page 308, is actually almost a full page of text talking about those transformer installations. So yeah, so the words are there, but the graphic, and Keith, you're right, that graphic's extremely busy. But I honestly don't know of any other way we can convey that information without putting it there.
You couldn't leave anything out. I mean, that's the minimum amount of information to convey on that one slide.
Yeah. Yeah, that
one thing
is.
when you're using the PowerPoint, you need to be careful. If you're an instructor and you're using the PowerPoint, be careful to always convey that sometimes in the graphics, not all the wires are shown.
Right.
They're trying to show a specific thing. And we try and make that point in SOARES, we make that point in the PowerPoint, is that in some of the graphics, not all the wires are shown, but we're trying to emphasize a specific item, particularly like separately derived systems, because that's one that builds on and builds on and builds on until you get to a full shown system.
Yeah. And I think especially when now this is system, and there's also equipment grounding and bonding in this picture too, right? So you've got both the system and the equipment. In a PV type of system, I know from personal experience that you may have a very beautiful PV looking installation where it looks like it should be on the cover of a magazine. But I've been with an electrical inspector when we got on the roof, and it's a big flat roof, and you're up there, and we get on the roof, and it was really funny because as we got closer to the installation, he stopped, he turned around and looked at me, and he goes, "Put both of your hands in your pocket and don't touch anything." And then he started to show me all of the bonding issues in that installation where things were not bonded. And he's like, his comment was, I don't know if there's a potential here, but there is a potential here. And we don't want to find out where, we don't want to find anything else out about this installation by touching anything, because bonding is critical in those applications. And in some cases, it's not done correctly at all.
I had an inspector call, and that was actually, he was doing plan review, and actually, I'm sorry, he was actually doing site review, and he called because he was really concerned. He had a big box store, and they had 2 megawatts of solar photovoltaic modules on the roof.
Wow.
They had 16 inverters, 480 volt output, 16 inverters, went into AC combiner box, 4 AC combiner boxes, basically taking 460 amp breakers in, and then a 400 amp feeder out on the main lugs, going to a 1600 amp disconnect at the service. And he basically said, do I have 16 separately derived systems? What do I have grounding and bonding wise? And how do I deal with all that? And again, thinking about, I'm going to look at system grounding, and I'm going to be looking at equipment grounding. There's 2 different things there, and making sure we have both of those covered. And they had cable tray, they had conduit, all kinds of things there that had to be bonded for fault issues and all. And of course the modules and the framing and all that, and the inverters. But then we also had a system issue, but the system only can be grounded at one place because it's all intertied via the neutral.
Right. And what's the new term that panel 4 introduced with regard to the
functional grounding?
Functional grounding, yes.
Which is another one of those terms. What does it really mean and apply it? I understand what they're getting at, but yeah, we get some additional terminology. It's a little bit like your source output conductor terminology.
Right. Yeah, exactly. Yeah. So, but terminology is, I think, really important. And what I love about this book is that it gets into all of those details. I mean, it's substantial. And it would be different if you sat down and said, boy, Tom, this is, it's 438 pages, but the letters are 1 inch tall. But no. there's questions, quiz questions, and the answers to those questions. So there's a lot of really good images in here. And I think that from a library perspective, I know my library would not be a well-equipped library without this one, because grounding and bonding is a topic that is confusing to a lot of different people.
Tom, I don't know how much time we've got left, but an example of that on slide 251 there in part 3.
We have as much time as you want to have, Keith. We can go for days, buddy.
This gets into grounding of when it involves electronic equipment. And you've got a very nice illustration here that kind of distinguishes between the equipment grounding system and your isolated equipment grounding system. And then the very next slide, Tom, bam. Gives us and keep hitting, because we got some identification there. Yeah, one more. And so, here's a real world photograph of what we just talked about in that illustration as well. And of course, most of the illustrations as well will be preceded by a text slide or two that gives a lot of Well, some of the information out of the book as well. So,
Yeah, and for me, Keith, this relationship between this slide and this slide, like when you say neutral bus, ice insulated from the enclosure, and you show the red backing behind that copper bus. When I look at
Right,
this picture, I go, okay, I see it. It's physically right here. I see this plastic piece here, and this
Yeah.
plastic piece that's setting, and this backboard, which is none of that is conductive, and it's separating this bar from the enclosure. That solidifies it for me in my mind, because I am, I don't necessarily look at this equipment on a daily basis, right? I mean, we make the equipment, and I get out into the field, but I'm a design engineer. I'm not out in the field anymore, right? And you have people who are in the field, and you need to make sure that they understand what they're looking at. And it may be different for different manufacturers, but you will always have that fundamental thing. You're going to be looking for that insulated piece that separates that bar, where down here, that bar is connected directly to the equipment.
to that cabinet. Yeah.
Yeah, or to the cabinet. So, and this one here as well. So, just based upon where it's located, if you saw a conductor wrapped in white, located on a lug that's directly connected to the equipment, and it's not service equipment, right? You've got an issue.
Yeah.
Yeah, we had a lot of fun, Keith and I. There was a graphic that had been used for some years where it showed a transformer with a system bonding jumper, and it had green phase tape and white phase tape on the same wire.
Oh, really?
And all that. And there's a funny story, as I know of an installation in Los Angeles, that's exactly how the main bond jumper is identified, because the inspector one required white because it's hooked to the neutral, and another inspector came along to try and get service energized. He said, no, that's hooked to ground, make it green, knowing the first inspector to come back. So it is actually a barber pole of white and green going down the whole main bond jumper for 4,000 amp service. And it was one of those frustrating things. The contractor was being told by the general, get power on for construction power, and they're trying to get through the inspectors, and neither one's right. There is no color requirement for a main bond jumper.
Do you know what's missing there? You said you have a barber pole, yellow or white and green, right? You know what's missing?
Yeah.
The red one, and you can have like Christmas music going on. Because that's the red tag that should probably be on that installation. Where else you want to go?
Keith, there's another one in swimming pools. If you want to go to 161, that's a good relationship too. So slide 161, Tom. So 161, 162, and 163 is a great set.
I love the swimming pool examples, because it's just.
So here's your graphic for a swimming pool junction box kind of setup, but then the next one shows a picture of those boxes and inside and out, and then the next slide is shows it in the pool area.
Nice.
So just again, that relationship visually and the graphic really comes in, and that's done in a lot of places in SOARES, particularly in the special applications, special provisions areas with signs, swimming pools, healthcare facilities, the low voltage systems like you've seen there. So.
See, I always thought that you're supposed to water those and they grow. I didn't realize that there was a termination inside of there.
Tom, if you don't, I guess we could end on that on this. But if you go to part 2, and go to like slide 30.
Okay, part 2. Hold on. I have part 2 already open. I'm going to close part 3. Now, what's really interesting, which slide?
Slide 30, somewhere in there in part 2. 30.
Sounds like a ground and electrode slide.
Yeah.
Yeah.
And, we were showing some pretty intense illustrations a while ago with the special conditions and special occupancies and things. And, part 2 is your common applications. And so, there's a lot of information in part 2 that is very useful, helpful. What is a concrete encased electrode? Well, here it is. There's 4 components, 4 conditions that a concrete encased electrode has to meet, and there's a and between all of those. It's not an or. In other words, if you meet 3 of the 4 conditions, you've got a big fat structural component that
Yeah.
doesn't qualify as a grounding electrode. So, we also have some illustrations and that kind of get down to the basics, of grounding and bonding as well.
One of the questions I get on that, Keith, all the time is thickened slabs. Can I a thickened slab that's got rebar in the edge? Can I call that a concrete case electrode? And the question is maybe, because it says it needs to be in a foundation or footer. Foundation and footers define in building code. And you got to realize the concrete case electrode is a building code item that the electrical people are using. It's not an electrical installation other than when you do the 4 copper wire.
Yeah.
Wait a second. What you said? A what in slab?
A thickened slab where you got like a monolithic pour slab where it's got a thickened edge. They make the edge a little bit thicker. Well, if that constitutes a foundation or footing on that thickened part, which in the building code will define certain dimensions to meet that to be actually a foundation footer, then yeah, you do. But if it's just a slab and it might be 6 inches thick instead of 4 at the edges, no, that doesn't necessarily constitute by the building code a foundation or footer.
Right. That just means that I dug the hole and I can't dig a straight hole.
Well, when somebody asks, especially in the seminar setting, if somebody asks me, does this thickened slab qualify, blah, 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 you take them right here and you say, do you have 20 feet or more,
Right.
yes, and if they answer yes to all 4 of your questions, then guess what? You got yourself a concrete encased electrode, and you cannot ignore that it's there. 250/50 says it must be used in your grounding electrode system.
That's right. And it's probably one of the best grounding electrodes.
Oh, absolutely.
Yeah.
Absolutely. There's
And
very
when's the
rare.
time? When's the time to utilize that thing? Right now. Wait, you
absolutely.
hesitated on me. We poured it. So
Well, so that brings up a good question, Keith. I mean, when you look at a diagram like this, when should the inspector be out there? I mean, the electrical inspectors should be a part of the process. I mean, do they have to be out there before they pour the concrete? I mean,
a lot of jurisdictions, Chuck can get into this. A lot of jurisdictions, particularly when we had the change at 250/50, what was it, 2005, I guess, somewhere in
5
there.
or 8.
Yeah. From if available to where present, it kind of forced jurisdictions to look at the way they were doing business. And so what a lot of jurisdictions started doing, and rightfully so, I believe, is giving some training to that footing inspector, that foundation inspector, and when he goes out to look at a footing, to look for something that could resemble a concrete encased electrode. And if he's not the electrical inspector, if he's not a combination inspector, then before I can let you pour this slab, I need to get the electrical inspector out here and let him look at this potential concrete encased electrode. And if it does qualify, if it does meet the 4 conditions, then yeah, we got to utilize this thing before I let you pour this slab.
So what happens
The
if
other side?
Go ahead, Chuck.
I was going to say the other side of that too is that for the electrical inspector to go out, is that the building code defines what the overlap's got to be. How do you do the tie wire? All that thing's building code, not the electrical code, which the electrical inspector probably has never been trained on. Is what is that? And different size rebar has different overlap. It's a multiplier of the diameter of the rebar if you're using rebar. And so it is there. And as Keith said, most times today it's the building inspector, foundation inspector that's doing the inspection of the item, and he's been trained of what it needs. And then you will leave a note or tag or some marker. Typically, sometimes they spray paint a little stuff up green so they know that it's actually been inspected as a valid concrete encased electrode.
Yeah.
Go to slide 32 there, Tom.
32.
And that illustrates exactly what Chuck was just saying.
I have to show it.
Yeah. All of that, all those tie wires, those are being installed by unqualified electrical people. Well, that tie wire is there to hold that rebar in place until I can get some concrete around it, basically.
Yeah.
And if you kind of keep going through there to the next couple of slides, talks about some of your connectors and having to be identified, listed for direct burial concrete encasement. And then I believe the next slide gets into the vertically positioned concrete encased electrode that has not always been recognized by the code up until, I guess, a decade or so ago, because up until that point, everything associated with a concrete encased electrode was kind of based on the original work of Mr. Herbert Ufer. And he didn't do any experimentation on a vertically placed concrete encased electrode. But, the code does recognize that now, again, if it meets the 4 conditions and so on.
Yeah, me and Herbie, we go back way back.
And probably the other thing, Keith, that comes out a lot of times with concrete encased electrode is when they put the vapor barriers or insulation or whatever in and around the concrete, so it's not in direct contact with the earth. People think if they got rebar in the concrete, it's a concrete encased electrode. It's not, because it doesn't meet that in direct contact with the earth requirement.
And that's why,
if you go to the next slide there, Tom, I mean, there's a slide there that talks about the quote unquote stub up of a concrete encased electrode. And, people get hung up on that one as well a lot. And I always kind of say, and Chuck, you verify this, that, something has to qualify as a concrete encased electrode, meet the 4 conditions. The stub up there really it's an extension of that. It doesn't add to the qualifications of something that has to qualify as a concrete encased electrode. It just gets it into an accessible location.
So Tom, if you want to use your cursor, the very bottom rebar, the horizontal one, is the concrete encased electrode.
Yeah.
The stub up is just a means of connecting to it, and it's analogous to the 5 feet of water pipe coming into the building. It's that 5 feet of water pipe's not in the dirt. It's not the electrode. It's just a way of connecting to the 10 feet of water pipe that's actually in the soil.
Yeah.
And guess what? We follow that up with. Go to the next slide. Boom.
Yeah, absolutely. So let me ask you.
The building inspector can, if you go back that one slide, the building inspector can do the inspection before the concrete pour of all that, including that stub up, which is great. Concrete gets poured. Now, when the electrician comes on site, he's got that to go to make his connection. He doesn't have to get there before the pour of the concrete, and that becomes a massive coordination problem for the generals a lot of times. And they have the electrician come all the way out to make the one connection. It's not going to take him 10 minutes, but it's going to be a 2-hour round trip drive. That's costing somebody labor time.
And I think too, some of the new technologies and I say new technologies, I mean, cell phones being able to take pictures is not relatively new. So if you were having good photos that puts things into perspective, doesn't take a nice little close up, I wouldn't want to show this to my inspector and say, look, I have a stub up. And they go, well, wait a second. That looks like the last 4 houses that you did, right? You got to show the perspective, but photos and documentation of the installation can go a long way to help the relationship between the inspector, the builder, and the electricians, right?
A good example of that is where you use the option for structural metal, and you have the columns with the J-bolts going down in the footer and all that. There's some good photographs of that footer and those J-bolts in intimate contact with that rebar is perfect. If you got those photos, then when you do that, and in the future, for future remodel work or whatever going on, from that documentation that column is in intimate contact with J-bolts, in contact with the rebar, and constitutes a valid electrode.
Absolutely. Yeah. This is a great discussion. We could go on for about 2 or 3 days, which, Chuck, I'm going to be asking you and Keith to come back, and we've got to think of, and I would ask anybody watching this, if there's a specific area of grounding and bonding you're interested in, you want to explore more in a discussion with a guy like Chuck and Keith and anybody else that we can get on the program that really is intimately involved with this from a code's perspective, from a practical application perspective, I would love to be able to bring some of that to this program and these IAEI resources. So I need you guys and gals to put that in the chat or send me an email, send Keith an email, send the IO, the International Office of the IAEI, an email, say, hey, I want to hear more about whatever it is, and we will make sure we bring it. And I know, Chuck, you're going to be a familiar face on this, hopefully moving forward. So.
Well, thank you. And I want to say that there have been a number of recorded seminars,
Yes.
webinars that are there. I know I did an 8-hour webinar, which is really part 2 of the SOARES book there. And there's been several 1- and 2-hour seminars on different topics that are available from IAEI right now. If someone wants to do a view webinar. And
I will put some links down for, there's a link down below that has the resources that Chuck just mentioned. I also have down below the link to purchase, because if you don't have this sitting in your library, I'd say you need to get a copy. And if you know somebody on your job site who could benefit from it, you know what's coming up, Chuck and Keith. You know what's coming? Yeah, Christmas. It's August, but it's but there is no better Christmas present than the IAEI SOARES Grounding and Bonding book, in my opinion. I'm going to get one for Bobby Joe.
I'm sure she'll appreciate it.
Beautiful. So we went over our hour, but that's okay. That's a little bonus material for everybody. So Keith, why don't you give us some parting words, and then we'll hit Chuck up, okay?
Well, I'm just thrilled to death to even be involved in this today, and it was a great discussion, and we gave a pretty good plug for the IAEI's SOARES Grounding and Bonding textbook and PowerPoint, but it's a great product. It really is. I mean, it's just a valuable tool. If you make your living in the electrical industry, be it an installer or an inspector, either one, or an engineer, it's a valuable tool. It's just a necessity, I think, that you have to have in your resources. And just want to thank Chuck for all of his involvement with the update of the SOARES material on behalf of IAEI. And Tom, thank you for all the work you do in putting on these IAEI live sessions here.
I'm you know what, Keith, I'm like I don't know, I'm living the dream, because I'm getting to learn from you guys on a planned program. So thank you. And Chuck,
I just thank you, Keith, and Tom. Tom, for putting this on. Keith, the collaboration work we've done together for several editions now has been phenomenal. It's a great work thing. I think, as everybody's going to know, I have a lot of passion in this area, a lot of interests and everything. So definitely, I just really enjoy doing just talking about this. It's just a phenomenal thing. And again, using the right words and really what Eustace SOARES tried to do from the very beginning. Let's get tradition behind us. Let's look at the facts and deal with the right language and what we're trying to do and understanding those fundamentals. And then we can make good, safe decisions on installations. Thank you.
Thank you, Chuck. Thank you, Keith. I really enjoyed this discussion. And thanks everybody out there for what you guys and gals do for the electrical industry and for electrical safety. We're going to sign off for now. Thanks. And remember, stay safe. And please, what is it? Stay healthy. All right. Amen. All right, everybody. Take care, and we'll see you next Tuesday.